Okay, let's go ahead and do an inspection on the air compressor. We've got a large Centak here. As we walk up to the machine, again, looking at the conditions in the area, listening to the sound of it. These compressors, the third stage, is sometimes spinning greater than 20,000 RPM, so you're going to hear a very high-pitched whine. As we walk up, we're taking a look at the cleanliness of the machine. There's the coupling guard. We've got a large AC induction motor, and the Centak is really a large speed increaser. It's a large gearbox there, and so as we're walking around and taking a look at the machine, there's the oil skid. Everything looks to be in order there. We've got our oil filter. Don't have a delta P across it. Don't have a gauge to let us know if the delta P is high. As well, it'd be nice if the filter was dated as to when it had been changed. One of the things we take a look at around this type of skid is looking at the gauges. Are all of our local gauges clean? Are they working? Are they functional? So that we can verify what we're reading in the control room with what's in the field when we do have something going and needs to be verified. That's when we need the gauges functional. So as we're walking around the machine, taking a look, you can see the motor looks to be a little bit dirty. The doghouse is a little bit dirty. There's a little bit of dust in the area, and we'll take a look at the tubing condition, the large motor junction box, make sure that the junction box is in good shape and that the gasket hasn't been compromised. But as we step back, you can see the oil smudge here on the floor or surrounding the machine, but it doesn't appear to be dripping from the oil skid itself. So when we notice something like this, the important thing to do is to continue to investigate and look around to see where the source of the potential problem is coming from. And so, as we look around the machine, we'll start to move around to the other side. There's a breather right there. We'll start to move around to the motor. Again, another oil smudge here on the side. And as we come around to the back side of the motor, again, the fins are looking a little bit dirty. And we can actually see the outboard bearing is oily, and the grease is probably gotten hot, and the oil is starting to leak out of the outboard bearing from overheating. So we're checking for airflow across there. And there's very little airflow. So the probably need to check or change the fin or the filters in behind those fins in the doghouse on top of that open motor. Yeah, the motor we're feeling, and again, the motor in this case is hot. We can take a look at the HMI, the human machine interface. It'll give us information like the load on the machine, and that way we can, when we go through and do a strobe light, we can take a look and verify, write down, document the load versus the RPMs that we're seeing. So as we're looking at the base of the machine and we're looking down here, there's the oil level indicator on the Centak, and what we see is that plug right there. There's our plug, and it seems to be dripping from that plug. And so, that's one of the things to, and then the machine is blowing that oil across, and that's what's creating that stain on the floor. So that plug may not be sealed all the way, and that needs to be addressed, and then we can remove that slip hazard. Here we are taking a look at the coupling. We've got a nice coupling guard with expanded metal. We can use a strobe light. A lot of times you'll have either a gear coupling or a metallic coupling, sometimes called a shim-pack coupling. And when we've got expanded metal like that, your ability to do a decent coupling inspection is really good. And so, provided you've got the strobe, now we're looking for signs of slinging grease from a greasable coupling, or if it's a shim pack, we're looking for any broken shims or any shims that are what we call canted or oil can, where they're actually beginning to be flexed and distorted. And so if that's identified, then that's something that we want to address before they start to fatigue the rest of the way, crack and break, and then have a coupling failure. So, you know, patience is required sometimes when we're trying to strobe, and the guarding and the way the machine is set up doesn't always allow you to see everything that you would like to. So, you know, as we're looking at it, I'm looking at the condition of the coupling, the bolting, the gasketing. Are the keys the right length, both in the motor and the machine, and are they opposite? So you want to see the keys fill up the keyway about halfway and be opposite each other in order to maintain balance in the machine. Okay, but sometimes it's a little bit difficult for us to see. But you know, with some patience, and sometimes it might require a guarding modification if there's some other failures that we'd like to inspect for, that the guard blocks us a view of. So as we go around, we then are checking some of the temperatures. We can check the temperatures of the stages of the machine and see whether whether it agrees with the local instrumentation. And again, document it down, do a good, thorough, documented inspection, and you know, keep looking for anything that is out of the ordinary, and keep listening. We'll put our hands on the machine, and feel for both heat and vibration. And so, as we're moving around, we're just continuing to collect the information, collect the data. Here we are on the outboard of the motor. We're getting vibration readings, both horizontal, vertical, and axial on the outboard bearing and the inboard bearing of the motor. You know, we'd like to get a good, true vertical. Sometimes we can't because of a grease fitting that might be in the way. Okay, and then get a good reading, clean off the spot where the magnet's going to go onto, and get a reading in the horizontal. Again, collecting the velocities and the GEs, and depending on where you set your alarm limits, you may have some further investigation to do.